Once you've familiarized yourself with the basic graphs of sine of x and cosine of x, you might want to graph a more complex function, like this one, y equals 1/4 sine of 2x minus pi over 2 minus 1. Now you want to start by thinking about the basic shape for the graph of just y equals sine of x. So that graph starts and ends at 0, at a y value of 0. You get your one cycle as x goes from 0 to 2 pi. You have another intercept right in the middle of the graph. Between those intercepts, the graph of sine goes up to positive 1, and then between those next two intercepts, the graph dips down to negative 1. So we're going to start with that basic shape when we graph this more complex function. Now we want to start by finding the x values that correspond to our one cycle of the graph. So one cycle for sine of x occurs as x goes from 0 to 2 pi. Now we're looking at sine of 2x minus pi over 2. So we're going to get one cycle for that graph as 2x minus pi over 2. The argument inside of sine goes from 0 to 2 pi. So we should start by setting up this inequality. This will give us the starting and ending x values for one cycle of the graph. We want to isolate x to find those values. So I'm going to add pi over 2 to each part of this inequality, getting pi over 2 less than or equal to x, less than or equal to 2x, less than or equal to 2 pi, so that's 4 pi over 2, plus 1 more pi over 2 gives us 5 pi over 2. And now, to isolate x completely, I'm going to divide by 2, or multiply by 1/2, whatever's more convenient. It's the same thing. So I have pi over 4 is less than or equal to x, which is less than or equal to 5 pi over 4. So these are my starting and ending values for one cycle of the graph. This inequality will take care of all of the horizontal transformations in your graph. So we've taken care of all of this 2x minus pi over 2 transformations from that. Let me start drawing. I'm going to use my pencil here. Oops. Things like that. And start drawing this graph. So I'm going to mark off pi over 4. And so I'll think of that as 1 pi over 4. 2 pi over 4, 3 pi over 4, 4, and then here's 5 pi over 4. So I know that my sine graph is going to start and end at 0. Now, I should say, I'm not considering any of the vertical transformations here, so we're going to take care of that in a second. Right now, we're only taking care of the horizontal transformations. So I'm not accounting for this 1/4 or this -1 at all. We'll deal with that in a second. For now, I'm just graphing y equals sine of 2x minus pi over 2. I'm ignoring the 1/4 and the -1 for now. Okay, so I'm just using the basic shape for our plain old y equals sine of x, except now I know that I want this graph to start at pi over 4, and the cycle will end at 5 pi over 4. Right in the middle, I'll have another x-intercept, and now we can just count. So here's 2, this is 3 pi over 4. Now, halfway between those first two intercepts, the graph goes up to positive 1. And halfway between the next two intercepts, the graph dips down to negative 1. So there's a sketch of our graph sine of 2x minus pi over 2. Now let's account for the vertical transformations. So what we were actually asked for in the problem is the graph of y equals 1/4 sine of 2x minus pi over 2 minus 1. So we still need to take care of the 1/4 and the -1. And we're just going to use our rules for transformations that we've been using all semester. When we have a constant times our basic function, that's going to result in this case, of vertical compression, because this constant is between 0 and 1. So So we should multiply the y coordinates by that constant, in this case 1, 4. Oops, let me slide the paper. And minus 1, we should shift the graph down 1 unit. Okay, so let's just do that to our key points here. And I should have darkened these 2 points. Those are also critical values in the graph, our maximum and the minimum. Okay. So the y-coordinate at each of these intercepts is 0. When you multiply that 0 times 1/4, it's still 0. But we also want to shift those points down 1 unit. So I'm going to go ahead and take all of those intercepts. When I multiply by 1/4, I get 0, but I want to shift them down 1 as well. And this is, we can think of this as C level for the graph. See how for sine of x, C level is the x-axis, where y equals 0. Now that we've shifted everything, shifted the entire graph down 1, now C level is here at -1. Alright, let me take this coordinate up here at, well, 2 pi over 4, which would be pi over 2. I can label that. Pi over 2, 1. If I multiply the y-coordinate, which is 1, by 1/4, I get 1/4. So that would compress that value down here, and then shift down 1. So if I subtract 1 from 1/4, I get -3/4. So my point will land here, right on top of my 2 from pi over 2. Sorry about that. I can see it in here. Let's see a little better. Similarly, here, let me take this key point down here. The y value is -1. If I multiply the y value by 1/4, I get -1/4, so about here. And then shift down 1. So if I'm at -1/4 minus 1, I get -1 1/4. -1 1/4. So this point right here was compressed to -1/4 and then shift down 1, so subtract 1. And we land here at -5.